Hello, everyone. Welcome to our next Julia Dispatch podcast. I am Chris.
And I am Michael.
And today we have some great guests. And I think that, Michael, you might have practiced the introduction here a bit more. You want to introduce our guests?
Sure. Yeah, I'm very excited about them. Today we have Yassin. He's a student from Egypt. And we have Alex, who's currently in France. And they will tell us about the Google Summer of Code project that they did. So let's dive right into it. Yassin, you were the coder this summer.
Yeah.
How did it happen? Tell us about it.
Well, it's actually quite a funny story. So me and my friends in college, we carpool often. So I was in a ride with some fourth year, I think, engineer in our college, and she was talking about last year's GSoC, and I was like, "Yeah, tell me more about it and stuff." And she told me, "Go and apply to Julia, try out your luck." And so yeah, she actually contributed last year in some library in Julia. I'm not sure which exactly.
Oh, okay. But so did you picked up Julia specifically for the Google Summer of Code, right?
Yeah.
Or okay. And so I think you told me you're an electrical communication student.
Yeah. Engineer. Yeah.
So how did this connection to
How'd you get
more
to
of a computer
Symbolics?
science?
That's a jump.
Yeah.
Well, I mean, I do some coding here and there, and we have a lot of coding courses in our uni. So it's not that big of a jump, because in the end, like Alex taught me a lot of theory, and I was just coding away.
Oh, okay. That's interesting. And Alexander, you were the person that mentored Yassin. So tell us a bit about yourself.
So I'm Alex. So thank you for the introduction. I recently finished undergrad in Moscow in applied mathematics and informatics, and now I am staying in Paris in Sorbonne University in Symbolic computation group. So, right, that's it.
Yeah, so bona fide card-carrying Symbolics person, bringing everyone together here.
How did it come that you studied mathematics and computer science? Like, is this something that you already knew that this was about to happen when you were a kid, or tell us a bit of the road to Symbolics?
Sure. So well, I guess I didn't really know what to do until maybe the last year of high school. I got quite lucky with my teachers there in high school. Because they, for example, was Vladimir Kurenkov who encouraged his pupils to participate in competitive programming. So I was very bad at competitive programming. I was maybe always placed last, but still I learned some coding, and then accidentally I got into a public lecture of Moscow university that specializes in computer science, and yeah, I liked it quite a lot, and that's how I ended up in basically in a faculty that teaches computer science. And then I had some. So you can say that in some sense I was trying to do things similar to what my teachers did. I was quite inspired by them in many ways. So I try to follow their steps. And then there was this desire to do things that other people can use and other people can find useful. So naturally, I drifted a bit towards applications, and so applied mathematics is something that's the interface. So
Well, a lot of people do applied mathematics that is not useful to people. What brings you to start making that jump and start saying, hey, let's actually build code that people are really going to use. Like, let's build open source packages and listen to users and fix their issues. Like, what made you take that jump in the first place? Right. So you see, there's a difference between, oh, hey, I've been doing my coursework, I've been coding for myself, and then suddenly you just say, okay, I'm going to write this pull request where some dude all the way on the other side of the world is going to tell me what's wrong inside of my code, right? Like, what made you take that jump? Were you just curious about how it would turn out, or were you like really like, oh, I really want to share this algorithm with the world? Like, what drove you to it?
I think originally when me and Alex were discussing the project, he asked me something along the lines of, "Are you familiar with any computer algebra systems?" So my only interaction actually with the class was Wolfram Mathematica. So last year we had a lot of physics courses, and I used Mathematica day in and day out to solve some equation which contains like 11, 12 variables. So to isolate basically the variable I want. So I was like, yeah, this is useful. Why not implement it myself with others?
Well, I imagine initially there was no such high-level thoughts in my head about writing code that will be useful to other people. But then once you develop an algorithm, say, and you code it, it might be a bit sad if you put it in some repo, you write nice documentation, you write nice README. It might be sad if no one uses it for one reason or another reason. So I guess my original question was, how do I make other people use my work, not necessarily for the sake to be useful, but just to get more publicity, let's say. And then it kind of became more. Then after some time, this question of how do I make my work more accessible? How do I make it more presentable? It was one of the questions I started with when starting a project. So it was a very gradual evolution from a student who takes mostly algebra courses, right? Who has basically zero chance of applying it to some real world applications. The gradual evolution from this to thinking about where it can be applied, where it can be used.
Yeah. I mean, I like to say that, open source code almost takes on a life of its own, right? You think you're working on one thing, and then, after a while, people just start asking questions, and you just start going, oh, wait, I think I could solve that. I think I could solve that. And suddenly you're going down a whole route that you never thought about before, right? Just kind of following your nose with the user and developer group. So yeah, I've definitely seen that story come out of you, because I mean, I think that you started with just a few pull requests here and there, and some, and then I started seeing you starting to do a lot of contributions to StructuralIdentifiability.jl has a lot of contributions from you. The Groebner basis library, so a lot of things in Symbolics, and I mean, you've grown to be a very strong part of the Symbolic ecosystem, and so it comes out of nowhere, but you really find a spot. It's always a very interesting thing. And so we're also happy to have Yassin also join in the last few months here.
So maybe that's a good opportunity to ask. So how did this specific project come along? So I think, Alex, you probably first had to propose the project to Google. So when did you know that okay, this is what I'm going to propose, or even that you're going to propose a project that you're going to mentor in the first place, right? Can you tell us a little bit about that?
Right. So this project, symbolic solving of equations, is something that is long-standing. Something is a long-standing issue in the symbolic Julia package. In a sense, if one wants to be competitive with SymPy, with Mathematica that Yassin mentioned, then one cannot do without some nice symbolic solving in such a system. So the need was there.
Mm-hmm.
Now there was now there was the need of someone who can do this. So for quite a long time, I think I had a pull request in Symbolics, which implemented partly what is currently done. But unfortunately, I never had the time to continue this work, or to finish that. So I suppose at some point, Shashi and me put out a form, put out a project description online, with the hope that we can find some bright students that can do the work, basically. So that's kind of the story in short. Right.
Okay.
I hope
And Yassin,
the question.
You've been the bright student that answered the call. Like,
Yep.
have you been drawn to the proposal early on, or did you know that this specific project would exist, or how was your experience browsing through, looking for projects that you want to join this summer?
To be honest, I was, as I said, I used Mathematica extensively throughout last years as a freshman. So I was like, yeah, I can do this. I think I can put like 350 hours into it without being that bored. So yeah, I was like, yeah, let's do it.
Okay. So you've seen that there's both working in symbolic algebra and computer algebra and in Julia, and that was what you had a laser focus on it.
Yeah.
Okay.
Yeah.
Cool.
Now, I mean, did the project end up similar to what you thought? Because I mean, when you start going into symbolic algorithms, right? You go down this rabbit hole with things like Groebner bases, ring theory, all this attracted, like this. You get to this whole new world of abstract algebra, right? I'm kind of curious, like what was it? Was the project along the lines of what you thought it would be, or did you kind of have to learn a whole bunch of new things on the fly? And how was that experience?
I mean, I did learn a lot throughout the project, but I think me and Alex actually over exceeded what we aimed at first to accomplish. So yeah, if you take a look at the proposal, we basically wanted to implement the basic isolation and attraction, along with our polynomial and multivariable solver. But yeah, I think as we progressed in the project more and more, the framework we built was very easy to build on and extend.
Yeah, and one of the things that really kind of drives a project is normally you kind of have like a spark or an idea in there, right? Where you're just like, oh, I think Mathematica is the thing in Wolfram's brain, and you're basically just querying Wolfram's brain directly and getting whatever the result is, right?
Yeah.
But I think I can do better than that, right? So I guess Alex, what was like the spark in here that kind of just been like, you know what, there is SymPy, there is Mathematica, but we're gonna do more than just remake their thing. Like what was the bit that was kind of driving you to think like I think I could do better than what existed before?
So that's a nice question. I think what has driven me initially was not this kind of aspiration to be competitive or better than other systems. For me, it was more internal motivation. Let's say I really wanted to. At some point, I really wanted to see some nice application of algebraic methods used by a lot of people in the wild, and doing some useful essentially what can be more useful than solving simple textbook equation. So then at some point I had a very brief look at SymPy internals, I think, and I was surprised by the fact that they used Groebner bases and other algebraic things to solve the simple equations. And at some point, as I mentioned, I had this very complicated and overly complex pull request to Symbolics where I tried to do things myself. But then it clicked that I can but then it clicked that I can use these algebraic methods in a bit more relaxed way, and they can still be useful. So it was basically a combination of things. So it wasn't at first it wasn't about comparing with other software, being better than other interfaces, but just making sure for myself that these symbolic things can be useful to a wide audience in some sense. So purely symbolic things.
Yeah. And I think that you highlighted something that's like very common in open source, right? That you had a first implementation where you're like, oh, this is how things are done. And then after you write it, you're like, okay, that's not how things are done. And take two is then, you're like, okay, no, well, I mean, normally with open source, we're probably going to have a take 3, a take 4, a take 5, there'll be iterations on it, right? But yeah, I mean, a lot of this seems like, daunting at first. How do you even get into symbolic algorithms? And then, you find this whole community and this math that's developed on it, and ways that they've brought this problem down to being modular, right? What I really like about the symbolic root finder that you've developed here is that it is very modular, right? There's like different little sections where you can say, okay, solve multivariate polynomials, solve, transcendental functions, right? And it's really just stringing together a bunch of individual solvers that are, in each piece itself is fine to read. And then, you have this whole system together that then put together. It's, amazing. It looks like it handles every case, right? But it really is, something where you broke it down into these other little pieces. And I think that that's a very nice design that at the end there.
So maybe before we dive into the nitty-gritty details of the algorithm itself, so something that I'm always really curious about is like the history and the development of how things came to be, and then where things will go from here. So one thing is well, probably very true for Yassin still, but maybe also for Alex, is the newcomer experience, right? The first steps into Julia. And so Yassin, you already told us that this summer was your first contact with Julia. So what was your impression of diving into this new programming language?
I mean, to be honest, the first couple of hours were like, this is Python, but with an end at every if statement. But yeah, as I used it further, actually the most significant thing I've learned throughout the summer is how to have a nice workflow when you're actually prototyping and coding. So I think early on, a month in or so, Shashi told me about Revise.jl, which was like a leap in my workflow. So yeah, that was quite well overall.
Yeah, before and after Revise is going to be a complete difference to your package development workflow.
Shout out to Tim, who did the first episode with us. So if you have not listened to that episode, go check that out as well.
He talked about how good Revise is to users, and here you heard it from the horse's mouth. So
yeah. And Alex, so I think for the newcomer experience is now a couple of years back, but can you remember the early days of Julia programming?
Yeah, sure. So, but let me say first that so I myself was a bit more. I was somewhat old-fashioned. I didn't use Revise. Every time I wanted, for some reason, quite some time ago, it didn't work for me, and then I never tried it again. So I had my own quite complicated workflow that I followed, and I perhaps missed to teach the right way to Yassin at the very beginning. and then he tried Revise and taught me back that now it's perfect, and so it improved my workflow as well tremendously.
Oh, I love these situations.
I had my own a lot of different small things to make it work fast enough. But yeah, with Revise it's just great. Okay, so to answer your question,
the best way to learn is to teach, right? That's what they say.
I suppose.
I remember me and Alex were in a meeting, and he was like, I told him he kept refreshing the REPL every time we changed the code. I was like, you can use it, and then he was like, no, forget it, forget it.
All right.
Well, I mean that does mean that we as a community do need to do more to be able to teach people some of these workflows, right? So people could be developing for years and not ever see like, oh, this trick with precompile tools to make your precompilation go down, or or all this stuff with revise, right? So there is a lot more teaching in a lot of this tooling that we should do, and especially with people who've been around for a while. I mean, you learn a workflow that works for you, and you just walk along with it. You're like, oh yeah, I got what I'm doing. And someone else, you show up to workshop or a hackathon or something. You're like, wait, whoa, you're really working fast there. What the heck are you doing? It sounds like there was these live coding moments really are the only way to show this. So we'll have to think about whether we do more live coding or live streaming or whatnot to kind of share these ideas. But glad to see it all worked out.
So, but Alex, what was your experience then without Revise? Like, obviously, you've stuck around Julia long enough to make it without so far that you became a mentor. So, what was that like?
Well, so I guess I started programming in 2020. So then it was so my first experience was Julia. So I absolutely loved it, and there was so already then I did some symbolic computation with Gleb Pogudin. So and back then there already existed some very nice packages for symbolic computation like Nemo, abstract algebra, and others. So it was a really nice experience from the very beginning. Regarding the development of code, well, I guess I had probably a different workflow. I didn't make many incremental changes and then check them online, but rather, I did that, but rarely. I rather wrote huge chunks of code, probably even separate scripts at first, and then combined it into something, into one project. So I reduced this overhead of reloading a bit, but with Revise it's still probably more convenient. Yep.
All right. And so I think now maybe it's a good time to really dive into the project and the work you've done. So maybe listeners are out there who do not know yet about symbolic computer algebra and this specific problem of root finding. So can you give us an introduction? Maybe Yassin, if some students will ask you when you're the fourth year student, what did you do in the summer of 2024? How will you explain it to the new student?
And just FYI, we can actually do screen share if you want to run a live demo. If you really want to live on the edge, we could also do a live demo.
I mean, when I explain it to my friends, it's more of like you have a calculator, a normal graphical calculator. It actually uses Newton's method or some numerical solver to solve whatever equation you give it. So like this, whatever it outputs is actually an approximation. So what we do is exact finding. So we use whatever analytic methods we have, like the quadratic formula, Cardano's formula, whatever, and we try to find exact roots which are accurate to infinite number of decimals. So yeah, and one application which again Mathematica is numerical methods cannot solve multiple, like a single equation in multiple variables. It cannot isolate and attract whatever equation you have. So when in our physics department in our uni, cannot use a numerical solver to actually isolate some mass variables in an equation.
And you also mentioned that you already used computer algebra systems in your study.
Yeah.
Maybe not extensively, but what are the kind of problems where you will in the future now get out Symbolics.jl and ask the system, hey, I need the solution. So where does it come up for you in your work?
Doing physics homework, basically. So I have this I don't want to write it out by hand. I just throw it at the computer and tell it to solve it itself.
Okay.
You ready to delete Mathematica now?
Yeah.
All right. Well, that means it must be pretty good. Mathematica is really good. I mean, I've been developing Symbolics for years, but I haven't really gotten to the point where I could say, yeah, we're fully past Mathematica in all places. But I mean, the Symbolic root finder is definitely a major change that is, one major step towards that.
Yeah. We do occasionally use it though to double check our answers because we're not that confident yet.
Oh, for sure. It's brand new. I mean, your code is brand new. So, like caveats and asterisks on it, but, it is out there and it is reviewed and it has test cases. So, so it is at that early stages. I mean, open source always goes through that early stage of where you when you're going to click that merge button, right? That means that you've tested everything that you're going to test, but you still haven't thrown it through 100,000 user codes to see all the details that they find, right?
Yeah.
So
also, I mean, in the beginning, you test against the established programs, and then as your implementation matures, eventually you'll benchmark against the competition. But it will always be around, and then at some point, it will just say we're faster and we find more solutions, and then you can sit back and relax until they get out a new version. So the project from someone uninformed about computer algebra systems, it seemed there was a lot of things that were in there, like single variable polynomials, multivariable polynomials, and even other nonlinear equation types. So maybe you can tell us, like, is this something that also is from the list of reading gets progressively harder as you implemented it, or is it the hardest was actually to understand how this is done in the first place, and then going from single to multi was not as hard, or so how is this?
I think it's
hierarchy.
counterintuitive, but actually the theory was the easiest part. So Alex gave me quite nice lectures about the theory, and it was easy to understand more or less. The hard part was actually dealing with Symbolics.jl somewhat. So we had a meeting like a month ago with Shashi, complaining about how complex noms are difficult to deal with. But yeah, so other than that, the project overall went smoothly. But the actual hard part was coding and like solving whatever type of coefficients and variables or equations.
And Alex, was the progress or the challenges as distributed as you anticipated when you laid out the project in your head? Like, did you figure, okay, maybe a student will struggle with this part, but then this will be easier, or were there any surprises?
So I can say about positive surprises, because this were kind of in the end of the project. I was quite surprised by how simple one can implement these algorithms, how one can build how so originally in my head I had a bit different picture of how it should go. I didn't plan up. So I knew for sure that we wanted some Groebner basis. I knew that we wanted some factorization, but I didn't connect it fully connected all of this into one working solver. But then I was a bit surprised by how seemingly easy, well, modulo some minor issues, how seemingly easy it was to connect this and to extend this by other methods that we didn't even plan in the very beginning, right? Like solving positive dimensional systems, for example. So I had a positive surprise for myself that something that I thought was quite complicated turned out to be much easier. And
yeah, but also some things that you thought would be uncomplicated might have been not as easy, right? Like, I think that we should probably highlight a little bit the the fact that one of the stickler points in this project for a while was just taking the exponents of complex numbers, right? You're going to write a root finder, and then you find like, oh, actually exponents of complex numbers aren't in the library as robust as we need to do. So let's sidetrack a little bit and fix that before we get back to the root finder, right? That's a very common, in open source we call it nerd sniping, right? Like you find an issue, another issue, and you're just like, okay, well, I guess we got to solve this one. You can end up in a whole train of other things to be doing as well. So there are some things that turn out easy, and then there's other things that that were found in this project, and I think you can only plan a programming project so much.
Sure. So I mean, but that I guess is to be expected, right? So from the very beginning, that Symbolics and Symbolic utils is relatively large systems, so they made some trade-offs for readability or performance or any other reasons that may be not too convenient for other purposes. So we needed, yeah. I guess it was to be expected. We would need some tweaks and tricks to make it work.
Yeah, Symbolics always has a lot of very interesting tricks in it, because it's a game of this. The simplest way of doing things is always exponential. So what can I do that's not exponential, right?
There was
Cool
this
stuff.
one thing that me and Alex actually spent like half an hour or some 40 minutes trying to convert polyform into nums. And so yeah, the types were actually difficult to deal with somewhat.
So that might be a good opportunity to talk something about also that is very interesting to me is I think in a very early draft of the proposal that I found, I think on the Julia website somewhere, was that it was supposed to have like this uniform API, but if I if my sneak peek at the pull request was correct, you moved away from this. So maybe like what other or tell us a bit more about this and the other API decisions that you had to make along the way to make this as user-friendly possible.
So what do you mean by uniform API? Because I'm not sure I looked at that early proposal.
That was I think the original proposal asked for everything should have a single solve method. And now I think it's called Symbolic solve.
I mean, yes, I think we called it solve at the beginning, while we didn't know that or I didn't know that other solvers existed in Symbolics.jl. So I wanted this big solve that contains everything. But in the end, we still wanted to do symbolic solving, actually. So, yeah, it was just a bad naming in our proposal.
Yeah, well, I could expand a little bit on that because I mean I did the code review that was putting down the line there, right? I actually want to just show something, right? So one of the things that happens in open source is that you have a lot of work that goes on in interfaces, right? So when we say there's solve, right? It turns out that solve has it turns out that solve can have many meanings, right, for different packages. So with differential equations we have solve, with nonlinear equations we have solve, with linear equations we have solve, right? So linearsolve.jl, nonlinearsolve.jl, differentialequations.jl, they all use the same dispatch, right? And so we started to put these rules on the open source ecosystem that's like, this is how this is how a solve should look, right? and it didn't fit the existing API. So it's like, oh, it's not going to be able to extend the solve well. So it's going to give you ambiguity issues and such. And the other thing that came into play is that there's also this solve linear symbolic linear solve that we had around in linear solve or inside the symbolics as well, right? And it didn't quite fit the API either. So so instead I kind of had this idea of, well, let's just change this out to be symbolic solve, so that way it doesn't interfere with the numeric libraries, because we're trying to unify everything between jump and SciML and all that, and symbolic stuff kind of didn't quite fit the form that we're trying to start saying is, oh, this is the standard form, right? So I actually kind of imposed that in my code review there. But there's a lot of reasons to we're trying to, as we grow the ecosystem, we're trying to enforce interfaces, and sometimes you have something Symbolics is actually a great case to talk about with doesn't quite fit into interfaces, right? Because a lot of the interfaces think about numerical computing, and once you start to put symbolic values in there, one of my favorite examples is you always think that if you do equals equals, right, x equals y, you get a Boolean value. It turns out that's not true for symbolics, because you have the symbolic expression x equals y, right? So there's a lot of these like interface pieces they have to start to be really careful about with symbolics, about am I breaking established interface? Because if I break established interfaces, then things that people are relying on in a very general sense, now there's a edge case that they have to worry about, right? So if I could get rid of these edge cases early in design, then I can make sure that they don't exist in the ecosystem. And sometimes that just is I guess we won't reuse that same naming here, because that naming implies certain properties, right? So yeah, there's a bit of history behind that, and you can go search a bit in the PR about that.
So to expand a bit also on the answer of Chris, I think originally in the GSoC proposal, we proposed to have a solver that would combine symbolic and numeric methods in some organic way.
Mm-hmm.
In the course of the project, we diverged from this original description a bit. So essentially, we implemented only symbolic methods. So we doubled down on symbolic methods, and the name symbolic solve was quite natural. So I think Chris proposed this name. It was a good idea in the end.
Mm-hmm.
So it's it's not only the interface imposed by Chris, but it is in fact I think a good name. And yeah.
Okay.
Yeah, I think it was called Solve till we actually made the PR, and Chris was like, name it something better.
Yeah. Well, and there was an existing solver only for linear variables inside of Symbolics.jl. It was called Solve4, which is the absolute worst name, right? It's actually so bad of a name that when they came to this project to start writing symbolic solvers, they didn't even know it existed in the library, right? That's just how badly documented it was, and that's how poorly searchable that name was. And so that's why I kind of thought, like, okay, this time around, like if we're gonna change something this time around, let's pick a better name.
It's like the Boy Scouts always leave the place better than you found it, and then that is the small piece that you fixed along the way.
And sometimes a small renaming is great. I mean, there are a lot of issues with renaming in open source, right? So you have to make sure you do proper deprecation. So if you call solve_4, it will get a deprecation warning that says, use solve linear, symbolic linear solve instead, etc. But it was a good time to do that renaming, because we also had new functionality that came with it, and also, this is how ecosystems grow. A lot of the names are not right the first time, especially within Julia. I don't know if people know Julia's history, right? But in version 0.6 to 1.0, there was actually this giant issue of like, okay, what are all the things that we should rename now that we have this years of developer experience? What should we rename? And I think the list was like 200 different things. So it's a very common thing in open source development. Yeah, I mean, again, you write the first version, the second version, the third version, and each time you get a bit closer to the asymptotic convergence to utopia.
Oh yeah, definitely. Something else that is really intriguing to me is, so Yassin, you're in Egypt. Alex, you're in Paris right now. You probably never met in person during the summer, or have you?
No, we haven't.
And so how was your experience for both of you fully remotely collaborating and think across the globe?
How about you answer it, Alex?
Sure. So, well. So this summer I had quite a packed summer, I need to say. So I traveled a lot, changed time zones a lot. So naturally, our communications were perhaps a bit. So it was not always online communication, but sometimes it was delayed by a bit. Sometimes we could not synchronize very well some updates, some meeting. I think one of the one of the not nicest moments was when I traveled to New York. So we had an even more gap between Egypt between Egypt and me, and yeah. So, but this is not the end of the world, I think. So different time zones one still can manage. As for example, we are recording this podcast. It's still quite fine for. It's still one can find options to meet and discuss if one wants to. So I think for me, for example, it was a fine experience. Perhaps sometimes I could have been a bit late answering something because of this difference, or maybe.
I mean, the time zones most of the time wasn't that bad. We were like 1 hour apart, so it was okay. I think me and Chris, for example, have like 8 hours apart. So yeah, that's quite more challenging.
Oh, I just plan to stay up all night. I mean, yeah, there's enough open source contributors that, you know, when else are you going to talk to someone in Australia and India and all that? So
I still need to get an eyewitness to actually confirm that Chris actually does sleep at all from time to time. Let's see how long it will take until I get confirmation on this. But so how was the remote work setup for you? I mean, you did mention that you also had like pair programming sessions. Like, did you actually find it useful to be on two machines and then always collaborating interactively, or were there moments where you wished, oh man, I would love to be in the same room and just go to the blackboard or whiteboard and write something down together?
I mean, I'm quite a solo worker. I like working alone most of the time, so working remote was actually quite fine. And I would update Alex on each and everything I do daily. And when I progress, like when there is noticeable progression, we meet and then he discusses, you did this, you did that, etc. But yeah, I do like working alone most of the time. It feels faster than being in person with someone because we'll just talk.
So from my side, so that's very interesting to know about your experience after the project. That's really that's really revealing. So from my side, I guess I suppose for me it's sometimes important if I have a list of questions, for example, that I don't understand something in Yassin's code or I have some bugs that I have found. For me, it was sometimes important to just come to the meeting and show an example and make us power through it together. But yes, so I guess for my workflow, it's sometimes important to have some let's say pair programming sessions or some online discussions.
I think reflections are really important and teamwork is very important too. But like for most of the work, I like having like 2-hour coding sessions just in silence, complete silence.
yeah. Well, the hard part of open source is not writing the code; it's reading someone else's code, right? That's So I think that's the key there, right? Like, yeah, you write a lot of code on your own, you put a code dump out there, but then it's all just like, okay, everyone else is then just like, wait, what is this code trying to do, right? And then there's that get together moment of trying to then bring that understanding from one person to an understanding for all, and then you're like, okay, now this code is part of the community, right? But yeah, I also like, shut out the world. Well, I like to keep my Slack and everything open, but yeah, shut out the external world. You just code for many hours. I mean, it's interesting. You'll see a lot of the big open source contributors. You'll see that, they'll go on these commit streaks that go like 8 hours in a row and then they're gone or something, right? And you're like, oh, I understand your process there.
Yeah. And you mentioned, so now I think the core of the work is done, but the pull request is not yet merged. So what
we merged
does
it. I think I clicked the button, right?
Yeah, it's
and
released as well, I think.
So I still had the page open from a couple of days ago when I last checked. Okay, it's merged. Congratulations. So what else is left for the project? I think there will be a final presentation also in some official format as well, for people who have not yet participated in the Google Summer of Code.
I'm not sure. Yeah, I think they have this lightning presentation or something, 2-3 minute presentation. I didn't apply it, to be honest, but I'll consider it.
Mm-hmm.
Oh, the presentation's a new thing. I didn't know that they added that.
Yeah, they emailed us like 2-3 days ago. We have this lightning presentation. Apply here. It's 2-3 minutes. Just tell us about your project.
Okay. But
yeah,
what else will be
new.
the So, but what else will be in the future of all of you with Symbolics.jl? So, Yassin, you mentioned maybe you will drop Mathematica at some point. Like, do you plan to contribute to Symbolics, or only if you get paid via Google again, or like, will you convince all your fellow students that, oh, this is my code, you should use it because it's the best code?
I mean, money is good, but yeah, I do intend on contributing again and basically polishing the solver, because it's my baby. I have to polish it, and then we'll see where we go from there. Also, Alex discussed Chris intends on applying the project in like 2-3 topics, or 2-3 other projects, model toolkit, I think, and some other ODE solver.
Yeah, so just to be clear to everybody, so at MIT in the Julia Lab, we have a lot of projects ongoing that are doing all sorts of things, right? So now Yassin is being pulled into one of those where we're optimizing some ODE tableaus, and one of the things that we need to do is we need to simplify out a lot of these polynomial constraints that come from the order conditions of Runge-Kutta methods, right? It turns out that this symbolic solver is kind of a perfect piece to fit into that project. So we're pulling him into that, and Yassin will then be a co-author and all that. So this is how the community grows, right? You probably had no intention before of like working with MIT Julia Lab on Runge-Kutta methods when you started, but now you're doing it. I don't think you have a choice. You're pulled into it. So yeah, I'm sure that things will keep on going in terms of because once you find the real application, I'm sure we will find all sorts of things to do next, right? And there'll probably be a lot to do, and that's why I want to have you on board here, just so that way when we hit that the new edge cases and such, we got you on call. So
that's great.
And Alex, what is next for you, either in terms of Symbolics.jl or within the Julia ecosystem, or like general?
Right. So, well, I guess I need to say that I'm perhaps mostly a developer of the symbolic methods, right? Not a user of all this. So for me, the interest is in developing new algorithms and trying them out, like perhaps making sure that they applied somewhere. Maybe helping other people to apply them. So staying somewhere at the interface between being the person who implements fast and correct algorithms, and being the person who sometimes uses them for anything in the real world. So more precisely, I guess. Well, yeah, as Yassin said, there are still a lot of things to do and things to fix in the solver, and it's it's certainly a progress, but perhaps I wouldn't yet delete Mathematica. So maybe Yassin, maybe wait until we make our thing works and it's all good. So in this direction, yeah, of course, there is a lot of missing features, let's say like that, that one can do for symbolic solving. It is not just polynomial equations and transcendental functions. We have many other things like equations with radicals, inequalities, and many other things.
Yeah, and also symbolic solving of ODEs and integral equations, right? And I mean, symbolic integrals is another one of those big requested features, which we got to get to sometime.
And this for sure, yeah. So with this project, I suppose there is still a lot of interesting stuff to do, and just in general, so I maintain a couple of projects that use symbolic computation in Julia, like StructuralIdentifiability that Chris mentioned, and the Groebner package that essentially is one of the cores of this new symbolic solver. So if I can somehow improve this, then basically everything that depends on those methods will also be improved, will also become faster. So I plan to continue maintaining it and for now doing some small changes, but then yeah, we'll see how it goes.
So is the roadmap of what you want to do next with Symbolics.jl already fixed, or like do you already have priorities planned, or is it something where if now people listening to our podcast and they are curious about Symbolics.jl and they have not like they want to use it, but their specific task is not yet done, should they contact you and then you will reprioritize your roadmap? Or
Yeah, definitely. I think that's a great idea. But me and Alex now plan on just writing a lot of tests because some parts of the solver isn't that well tested. So that's our top priority, I think.
So yes, Yassin did put out a small blog post, basically inviting other people to try out and to find any bugs and to submit any feature requests. So, but and of course, other than that, people outside are welcome to tell us what they would like to see, and I think so since with this kind of solver, the final goal is that it will be used by people, it will make sense to prioritize implementing things that people want. So, yeah.
So you heard it here first. Even Chris's cat seems curious about Symbolics.jl.
Yeah.
And
Oh,
if
very.
you listening to this at home, we will put the blog post that Yassin wrote into the show notes. And we will put also the link to the pull request and just the Symbolics.jl in there. And if you want to check out, give it a try. If anything is missing or not as expected, either contribute yourself or just open an issue on GitHub, and Yassin and Alex will jump right on it. It sounds like
make your demands, but very nicely.
always. So, Yassin, so you are just in the beginning of your studies. You just got paid for your first code contribution, which is way earlier than I got paid, and I even studied computer science, and all the projects lined up for you as well. So will you try to you already mentioned that you will try to stay in contact with Symbolics.jl and with all the rest of the ecosystem, but is Google Summer of Code something that you will follow as you progress? Like, will you tell other students to join as well, or will you one day mentor now that you've been the mentee?
I think GSoC is a really nice experience to students here, especially because most of work here is not like science related. So GSoC does open opportunities which is not available in a lot. So it is a good experience, and I do plan on contributing again if I find some attractive project similar to the Solve.
And Alex, was this your first Google Summer of Code project as a mentor as well?
So not precisely. Well, in short, I think in previous year I also mentored one project. Yeah. So not my first experience.
Okay.
You're with the symbolic structural identifiability one, or?
No. For that one, I was a student, I guess.
Oh.
Okay. But you will mentor again now that you've been the mentor this time. Like, how was that experience for other listeners out there who are considering to propose their own projects?
Sure, I will. I mean, it's very fun, and as I've mentioned, I learn a lot of stuff like using Revise and other things. So it's not only so it's useful, of course, not only for the student but for the mentors themselves. So yeah, I like it a lot. I will participate if there will be an opportunity.
Sounds great. All right. Chris, is there anything that you want to ask before I have one final question lined up?
Go with your final question. I'll see if I can come up with a final question myself after.
All right. The one final thing that I'm very curious about is, again, concerning the future, now that you had this experience with Google Summer of Code, with Symbolics.jl, with Julia, if you could make a wish that someone else would solve any problem that you've encountered this summer, either with Julia or with Symbolics or something, breaking or non-breaking, what would it be? What is the call to action that someone somewhere out there should just solve for you?
Complex norms in Julia. Yeah, I think this is of utmost importance.
Yeah, complex numbers in Symbolics is definitely an open issue, and we've been poking at Shashi a little bit here and there to get exactly what you needed for the project, but it's definitely not enough. We need a lot more support for complex numbers. So yeah, that is definitely one that is known.
Alex, what is your number one wish?
Oh, I mean, in the frame of this project, I was mostly happy, right? I mean, I didn't do heavy lifting with this code. So it was so Yassin did all the struggle with the code. I learned.
But in general, what are you unhappy with? I think you're talking about to your therapist about computer programming languages, right? What is making you unhappy right now?
So there is this one thing, right? There is this one thing, and it is I suppose memory management in Julia.
Mm-hmm.
So I'm not at the point of being unhappy, of course, but once one gets into Julia, in a sense, he or she may become greedy for performance, for readability, and for greedy for combining all these things together, and naturally one would want to go 100% on both. Sometimes it becomes quite tricky to do that in Julia in terms of memory management and garbage collection, especially in multi-threaded settings. But yeah, that is just one small thing that I wish to could be changed somehow.
Yeah, we'll definitely have to have Gabriel and the NVIDIA crew on the new MMTK garbage collectors come on and talk about the future memory management. So that is definitely a hot topic right now that's going on in the compiler discussions. So yeah, that is one to highlight, that for sure.
That is really great to hear. Yeah.
Yeah, well, I guess if I had to throw out one last question to this, there's lots of cool functionality all over the whole world, and we've mentioned like here we said, oh, there's this cool thing in Mathematica. What do we need to do so that way we can have like a good open source implementation of this, right? Are there any other technologies that you kind of look at and just say, oh, hey, I really wish this was in Julia? Like maybe start with Yassin here.
Maybe start with Alex. I want some inspiration.
You want what was the answer there?
Maybe start with Alex. I want some inspiration.
Okay.
Yeah.
So Alex.
So Chris, if I understand correctly, the question is: are there any technologies in other like frameworks or languages that I would like it someday to see in Julia?
Mm-hmm.
Sure. Well, I suppose. So I do not have a reference point here. I don't have a good language to compare to, unfortunately. I have some ideal language in my mind that I can compare to. So
is it Lisp?
Actually,
I'm kidding.
No. So one thing I guess I would be happy about is to have a way to have more ways to impose some static constraints on your program. To impose an interface for a type, let's say, or impose some invariant in the entry of the function as the output of the function. Let's say have const input arguments for functions, to stuff in this direction. I think from my perspective, it would be nice if there would be more static tools for ensuring the correctness of the code and performance of the code. That's kind of
Yeah, there's a lot going on with that static Julia. And Yassin, do you have any that you would add?
Yeah, I think it's not a technology, but I'd like more people like in the mainstream academia to actually use Julia daily. So I'd like my physics department to use Julia and symbolic solvers rather than Mathematica. So maybe there is a leap to be, or there is a jump to be jumped between Julia and the technologies of Mathematica and MATLAB. So yeah.
Well, Julia does have a jump library, so. But yeah, we definitely have to do a lot more, training and workshops and getting more people involved with the community. And now you're someone that's entered there in Egypt. Actually, I know that there's another contributor or two that are like some contributors to the compiler who actually are also based in Egypt. And there's also been some Cairo Julia meetups before. So maybe we'll have to, find that local community and grow it. I'll go all over the world. So if you need me there, I can show up.
And we have to spread the word. And this is what we did here today, or that is what we're trying to do here. Thank you a lot for your time, Yassin and Alex. It was wonderful having you. It was wonderful learning more about Symbolics.jl, about Google Summer of Code and your experience. Thanks to all the listeners for listening in. And any final words, Chris?
I don't think any final words from me, other than that there's no other final words.
Let's hear you again in the next episode. Thank you, everybody.
Thanks for having me.
Thank you.